So good evening everyone. Welcome to this channel. So in this channel we will deal about the 10th standard chapters of chemistry and biology. Okay. So now we can start the chemistry second chapter, acids, bases and salts. Okay. So what is acids and what is the difference between acids and bases and the salts? We can learn about these differences and the properties of this acid, bases and salts within this chapter. Okay, so let's start our class. So you know that when you already have learned about the characters of this acid, bases and salts, right? So what are the characters of this acids? What is the taste of this acid? Acid will generally have a sour taste, right? What about the base? It will have a bitter taste. So when you are taking some acid in your daily life, you may be using this lime water. It is an example of acid, right? So it will have a sour taste. Okay. So when we are tasting this acids, we can say that most of the acids will have a sour taste. And when we dip this litmus paper, you have already seen the litmus papers, right? So when we dip this litmus paper into the acid, it will change the color from blue to red. And if the litmus paper is having red color, and when we are dipping that red color litmus paper into the acid, there won't be any type of color change. So the color of this litmus paper, when we are putting it in a acidic medium, will be red color. So similarly, when we take the case of bases, when we take the litmus paper and when we dip that litmus paper into the bases, the color will be changing from red to blue. Or if the litmus paper taken is already in blue color, there won't be any type of color change. Okay, so when you are observing this slide, you can see that the acid is having loads of H plus ions over here, right? Here you can see so many H plus ions over there. And when we take the case of bases, there are so many OH minus ions. And here we have another case, that is salts. And NaCl, salt. Salt is an example for salts itself. Okay, the NaCl, when we are taking it as NaCl, and we can divide this NaCl into Na plus and Cl minus. That means sodium and chloride ions, right? Na plus and Cl minus. Okay, when we are taking an acid like HCl, we can divide this HCl acid into H plus and Cl minus. Similarly, when we take the case of base like NaOH, sodium hydroxide, when we are taking this NaOH, we can divide them into Na plus and OH minus ions, right? So when we compare the case of acid, bases and salts, we can say that acid is having a sour taste, and when we take the case of bases, it will have a bitter taste, and the litmus paper will change its color from blue to red in case of acids and red to blue in case of bases. Okay, so we can say that these are the color change of litmus. So litmus paper, when we are talking the case of litmus paper, actually this litmus paper is used for detecting the nature of acids and bases. Okay, so actually we are using this litmus paper to detect the nature of the solution, if whether it is acidic or basic. So similarly we can use so many indicators. We can call this litmus paper as an indicator. That means they are indicating whether the solution is acid or bases. Similarly, we can use so many indicators. Okay, here you can see that when you are using this blue litmus paper in acidic medium, the blue litmus paper is actually changing into red color. If we are using the red litmus paper to detect this acid, then there won't be any type of color change in case of this red litmus paper, because this in acidic medium the litmus color will be already in red. Okay, so when we take the case of basic medium, the color of the litmus paper will change from from red to blue. That means if you are already taken the blue litmus paper, there won't be any type of color change. Okay, so we are using this litmus paper to indicate whether the solution is acidic or basic, right? So now we can see here that there are so many types of indicators. We can divide this indicators into, indicators are used for detecting the medium, whether it is acidic or basic. Okay. So actually we can divide this indicator into natural indicators, synthetic indicators and olfactory indicators. So when we are taking the case of natural and synthetic indicators, they will change their color in acidic and basic medium. But there is difference in case of olfactory indicators. This olfactory indicators will change their order in acidic and basic medium. Onion is an example for olfactory indicators. Okay. So these olfactory indicators are the indicators which is used for detecting the acidic and basic medium, but there is no color change in case of olfactory indicators. There is only change in order in case of olfactory indicators. So they will change their order in case in acidic and basic medium, so that we can detect whether it is acidic or basic medium. And an example for this olfactory indicators is onions. Okay. So when we are moving to natural indicators, we can say that litmus paper is an example for natural indicators, because litmus is made up of paper, right? So it is a natural compound. So we can say that litmus is an example for natural indicator. It will change its color in acidic and basic medium. And when we are moving to the turmeric case, we can say that it will change the color from red to orange and orange to red in case of acidic and basic medium. Most of you have experience by using this turmeric as the natural indicator, right? If some curry is poured over your dress, it will change the color from yellow to red when we apply soap on the on that cloth, right? So it's an example for natural indicator. So we can say that turmeric and litmus are examples for natural indicators. Okay, then we can move to the synthetic indicators. Synthetic indicators, we can give examples as methyl orange and phenolphthalein. They will change their color in acidic and basic medium. Okay, so we can take the case of phenolphthalein. Okay, phenolphthalein will have a pink color in basic medium. Alkali means base. Okay, that the bases which is dissolved in water, we can call it as alkali. Okay, the bases which are dissolved in water, we can call it as alkali. So in basic medium, actually phenolphthalein will show which color? Pink color. Okay, in acidic medium there won't be any type of color by the use of phenolphthalein. And in acidic medium, when we add 2-3 drops of phenolphthalein to the acidic solution, it won't change any, it won't show any color, it will be colorless. Okay, when we are taking hydrochloric acid or HCl, and when we are adding 2-3 drops of phenolphthalein to it, there won't be any color, it will be colorless. And when we are taking this potassium hydroxide solution or sodium hydroxide solution or calcium hydroxide solution, and when we are adding this phenolphthalein to this, the color will change to the pink color. Okay, so similarly when we take the case of methyl orange, we can see here that in basic medium it will show a yellowish color, and in acidic medium it will be a reddish color. Here you can see correctly. Actually the color of methyl orange is almost reddish color. In acidic medium it will have a reddish color, and in basic medium it will show a yellowish color.